Okay, so this is the third part, part C of the dplyr introduction. Let me go ahead and share my screen here, and things are pretty much right where we left them. If you haven't done the earlier parts A and B, you probably should. So let me put all of these packages back in, and we'll load our 3 data sets that we had. Titan Alive, where we just filtered for those who survived, and Titan Young, where we filtered for those who were under 21. All right, so before we get into our fourth command, mutate, I want to talk for a second about pipe chains. Now, a pipe is a way of connecting multiple lines of code so that we can do more complicated things. Now, you've already used a pipe, and down here in line 20, I already have it, but in ggplot, we used a plus sign to represent a pipe. And so we were able to start doing more complicated things. So here I made a quick plot, ggplot, the data is the Titan data, the mapping Y is the age, and the X is survived, and the fill will also be survived. And let's see here. So all I did is I made a quick plot here. And the plus sign was how we went from one line to the other. And if we decided we wanted to add something else to it, we could do that pretty quickly. The command for label, and you can see here I'm pulling up my ggplot cheat sheet so that I remember how to add labels. Labs is the command for that. And if we want to give it a title, we would just do title equals age by survival on the Titanic. Okay, and all I did was that plus so that I could do that. And now when I rerun the plot, it looks the same, but now it's made the title. And I should probably capitalize that and do all those good, do all those good things that we do. But the plus sign is just a way to say, keep going, and we want to build on what we had before. And just like we could build a fancy graph, we can build changes to a data set in the same kind of funky way. So the command we're going to use for that is a funny pipe, and it's the dplyr pipe, and it is % greater than %. And there's nothing to say other than that's a really weird pipe. % greater than %. I've done this for years, and even now it's a little bit tricky to get that under your fingers. Eventually you'll get kind of a groove with it. Hadley Wickham, the guy from New Zealand who's the main coder of the tidyverse, he explained that he picked this because no one else would ever use % greater than % for anything else. And I have to give him credit. It's hard to argue that there's some other piece of code that's going to use % greater than % for anything else. So when you use the pipe in dplyr, you don't need to include all of these lines as we build through. So if we just want to make Titan pipe, here's a new, just a test one. It's going to be Titan. I'm going to put the pipe in. So far we haven't done anything. I've made a new variable, a new data frame that's equal to the old data frame. You hit return. Notice that our studio knows that you're doing something crazy because now it's indented a little bit so that you can keep this pipe chain together. So now we're going to filter survived. Is it going to be equal to yes? That's just what we did up above. Put another pipe. I'm going to filter age to be less than 10 for no particular reason. And the pipe chain is still going. And now I'm going to arrange by age, one more pipe, and select minus survived. Remember, that's what we did last time. Thanks, everybody. Oh, I could have done the 10 thing. Okay, so now that we've done that, you can see that the whole group is done. So here's Titan pipe, and it now has only the 50 people who are left who survived and were under age 21. It still has sex, age, and passenger class. Now, when some people talk about languages and packages like tidyverse, they sometimes call this self-documenting code, which I think is a little bit pretentious. But the idea is that it documents itself. As you look here, you can say, oh, I made a new variable called, or a new data frame called Titan pipe. It's assigned to be Titan. I filtered it by those who survived. I filtered it by those who are under age 10. I arranged it by age, and I got rid of that variable. So even though we did 4 different commands, it's actually pretty easy for your eye to look down and see what's going on. Also, if you look at these, it kind of looks like you're actually coding. You've made a script that you could actually use for stuff. Now, another advantage of pipe chains and these kind of scripts that you can keep around is you can imagine that your data set grows every week. Now, hopefully the Titanic set is pretty well done. We're not adding new names to the list of people on the Titanic, but you could imagine that every week, each store at your company enters their sales data, and every Friday afternoon when they close for the weekend, they're going to upload how much their store did in sales. So Monday morning, you're going to come in to your office at the central office, and you're going to run sales data for the week before. You're not doing anything differently, but you have new data to include in your data set. Having a script like this makes it really easy to just go in and run the same analysis on a new data set. You could imagine that every week you have to give sales data to your boss, or every quarter you have to make a report that goes out to shareholders, or anything like that. And if you have this script in place, you can just upload your new data inside, right? Nothing we did here changed. If the data set Titan changed, then our conclusion is going to change. And whether you're making plots or you're making data sets, having these sort of semi-automated scripts will allow you to do things. There's even a package called Shiny, which allows you to make web-based apps. So you could imagine your boss doesn't even have to get the report from you. He can just go in, enter the dates he wants, and recreate this report for whatever. Okay, back to our new command, which is mutate. I'll demonstrate it first without pipes, and then later on I will bring it all together here as we get to where we want to be. So mutate makes new variables out of old variables. So maybe you could imagine that we were interested in all these babies and small children that were on the Titanic, and we really did want to know how many months old all of them were. Maybe your division by 12 skills weren't quite as on point as other people's. So we make a new variable called Titan month, and we put in mutate, and now we put in Titan young, and we make a new variable called age months equals age times 12. Okay, so all we did there is we made a new variable, and now you can see that we've stuck it on the end, and in case you were wondering, right, 0.917 years, in fact, is 11 months. And so that's kind of funny. Of course, 19-year-olds are 228 months old because older people just round their age to the nearest year. And of course, this one is pretty boring, but you could imagine doing fancier things where you need to mutate variables. Maybe we do want to change all of the dates into a different format, or we want to change centimeters to inches, or degrees Fahrenheit to degrees Celsius, or whatever. You could also imagine doing a whole bunch of cleaning techniques where we're going to use substitute, which we'll talk about in the lab assignment here a little bit, where we're going to clean our data by directly mutating a variable to have different values rather than the ones that they were assigned. And again, I'm joking about this idea of self-documenting, but the idea that you're going to write code that someone else is going to use, or someone else is going to write code that you're going to use, or you're going to have to show it to a group of people, and having it be as clean and clear as possible is going to really help you with that. Now, you could use the hashtag and put in a bunch of comments, and of course you should do that when it makes sense, but the fact that tools like tidyverse and dplyr are so clean and clear to figure out what's going on. And so this addition, I think, can really help with making things clean and clear to have this kind of self-documenting idea of code. All right, so finally, let me put these together with the pipe. And again, this idea of making these big, long scripts is maybe something that you're not super excited about, but I can give you an example. Here at Truman, for many years, I was the director of the portfolio project. And you guys probably know about the senior portfolio. The portfolio is where you put papers and other artifacts of things you wrote. Then during your senior seminar or in your senior year, you go back through and find your best work, your best material to submit. You do a little bit of reflection, explain what's going on. And every year the portfolio group, the portfolio director, issues a report, and it has charts of, how do business majors write compared to chemistry majors versus history majors. And, every couple of years we get a new major. Stats is a pretty new major. Biochemistry is a new major at Truman. So you have to go in and change the scripts. You can't just run them directly. But other than that, every year you come in, you get new data, just like that sales data I was talking about. You turn the crank and you make these reports. If you go to assessment.truman.edu, you can see the reports they made. I was portfolio director until 2013. So if you go back and read those are the ones that I wrote. Now, when I took over the project in 2008, all of these reports were being run in Excel, and there was a very clear documentation of how you would generate these charts. But you had to do each command manually, and you had to have a record of it so that someone else could know that you didn't cheat with the data, or you didn't leave anything out, or you didn't make any mistakes. And each summer it took me about 60 hours to do all that report. Excuse me, about 60 hours to run the report. Now, you know that I'm a faculty member and I don't get paid by the hour, but 60 hours is a lot. And even if you think my time isn't very valuable, because I'm a lazy faculty member, doing 60 hours of report writing is actually a whole bunch. It's more than a whole week, about a week and a half of full-time work. Now that we've done the update with tidyverse, it now takes about 4 hours to run these same charts and graphs, and it can be done by a student. And again, if you can imagine that I was paid hourly, and in fact I was working as a consultant or as a statistician, I would charge more than a college student would charge. So if you were an outside company hiring me as a consultant, would you rather hire someone at my wage for 60 hours of work, or would you rather hire a student for 4 hours of wage? It's not a very hard decision to say that making code that you can script that can be reused saves time, which saves money. All right, anyway, before we finish here, let's stick a mutate command into our pipe chain. So I'm just going to go back up to here. I'm going to actually make a copy of it so that we have a record of that last one. Then I'm going to go in here and put it in the middle for no particular reason. Mutate age months equals age times 12. And remember to put the pipe chain at the end. Remember, the last one doesn't have a pipe chain. I'm going to call this pipe 2 so that we can keep them separate. And I went ahead and run it. And now you can see pipe 2 doesn't have 3 variables. It has 4 variables because we've actually added one to the end. All right. So there you have it. 4 commands are now done, as well as the awesome and amazing magical pipe chain, which uses pipes, %, greater than, %, to allow you to make some really long and really interesting scripts. We have one more video in the sequence, and that's going to talk about summarize and group.